Hey everyone. So our next area, we're going to start to go and continue through properties of angles and triangles, and we're going to go through parallel lines. And similar to before, I would encourage that you pause the video along the way and copy down the notes. It will help with kind of explaining how to go through this process. So we know, or kind of remember from before, parallel lines, I often say they're like train tracks. Their definition, they're two lines that never intersect with each other. They always stay the same distance apart forever. Transversal lines, they're lines that intersect two or more other lines at distinct points. So we have basically the red line that's cutting these two black lines or intersecting these two black lines at distinct parts. And so because of this, there's some properties that kind of arise. So for instance, just as kind of an example with the basketball net, sports equipment manufacturers, they build portable basketball systems. And if you've ever seen one of these, they have little handles that you can raise and lower the backboard. But the thing is they have to keep the backboard the same vertical trajectory from the pole. And so they never tilt in or out, they stay vertically upward. And so this is known as a transversal. And so a transversal intersects two parallel lines, and it's a really specific scenario. Okay, you have two parallel lines, and we have a transversal line that's between them. So these little arrows, they mean parallel. Okay, so we have parallel lines when you see these arrows kind of inside of them. And then what we get from this is this highlighted point in here, and these really are our properties that we can start with. So when I have a transversal, and I have two parallel lines that it intersects, then the outer angles end up being the same. So the outside angle that would make here is the same as the outside angle that's here. Okay, these would be identical. Same thing when it's lowered, our inside angles end up being the same with this transversal. So we're going to use that idea and make a few little properties or conjectures. So using the relationship that you just observed to predict that measure, I would encourage that you pause the video, take a look at this, and see if you can explain how each one works or what happens. Alright, so if we have this being 140 degrees, then that's the only one that we know. But we can make a connection to some of the things from before. So we have two sets of parallel lines that are here. And I know that if this is 140 degrees, then right away I'm thinking, okay, the opposite from my other angle properties must also be 140 degrees. So my B is 140 degrees. Now, after that, from the video or from the slide that we just saw, I also know that angle F is 140 degrees because the outside angles are going to be the same. So F is 140 degrees, and that pops up from here where I can see that I have two angles on the outside that are the same when I have parallel lines with a line intersecting it. So that also means then that E is going to be 140 degrees because they're the same. And then after that I look at this and think, okay, I've got straight lines now everywhere, right? So I know that in a straight line, this has to total up to be 180 degrees. So that means that A is going to be 40 degrees, and that's going to match up the same way with C being 40 degrees, which is also the same thing as D, which is 40 degrees, which is the same thing as G, 40 degrees as well. So we can use these angle properties to kind of solve a lot of different problems. Now there's a few different specific types here that I'll get you to obviously pause, copy them down, so you have them. They go along with the complementary and supplementary angle stuff from a previous video on angle properties. So we have, with parallel lines and a transversal between them, we have these things called corresponding angles. So corresponding angles are equal to each other. So A is equal to B. Now, what you're looking for here with parallel lines is that it kind of makes this F shape. And so this also sometimes can be known as like an F theorem. I've also, in other math classes, heard different names for it. But as long as you can kind of recognize that F shape that shows up in there, then the inside parts are going to be the same. I also have an alternate angle theorem, and in my alternate angle theorem, A and B are equal to each other the same way that they were in my corresponding angles. But in alternate angles, I have parallel lines that tend to make this Z pattern. And so in here, I have inside angles being the same. So in my Z pattern, sometimes I've heard this called the Z theorem, but alternate angles is kind of the appropriate term for it. I also have interior angles, and in this case, interior angles add up to equal 180 degrees. So they kind of make this C shape. And so, similar to the other ones, oftentimes this is like the C theorem. Okay, or interior angles would be the appropriate term for it. So they add up to 180 degrees when we see them. So there's 4 different kind of questions here. I'll get you to pause the video, try each one out, and come back and we'll solve them and go through them. Alright, so to calculate the missing angles, there's 180 degrees in a straight angle and 360 in a full turn. So what that's kind of telling you is all the way around the outside, I know that if I take all those angles and add them up, I should get 360 in a full circle or in a full turn, and 180 degrees in a straight line. So because of that idea, then B must equal 150, and then opposites are going to be equal to each other. In my next one, I've got the same kind of idea where y is 108, and then I know that this one is going to be 72 because I have to add them to 180, and then opposites are going to match up to be the same. Same thing here, I'm going to get 66 degrees, and then I'm going to have 180 minus 66, which is going to give me 114 for the other ones because of opposite angles, and then the same thing here, opposite angle 77. And so I've got 180 minus 77, which is going to give me 103 for each of the missing ones. So we kind of have this similar property here where we can check all these angles fairly frequently. So in summary, we've got some key ideas. When a transversal intersects a pair of parallel lines, then there's different properties that we can form between them. And we can kind of see here what those represent, where we have A equal to E, or B equal to F, C equal to G, and so on. What we need to know from this is that we have these transversal lines, then there's a lot of different properties, but they have to be parallel to each other. So if we have non-parallel lines, then these corresponding angles are not equal to each other, so they need to be parallel to work. Okay. We also have a couple new terms corresponding alternate interior, alternate exterior, and interior angles to follow. So we'll use those to move on with our next topic.